All right, simplifying trig expressions. So if we have just, something fairly simple like sine of x times cotangent of x, how does that simplify? What should we do? We've already done this. So what do we do on this? Change cotangent into cosine of x over sine of x, and those cancel to be cosine of x. Okay, that's a very simple one. We've already done this. That's what we'll be doing in this first little section today. Now, let's say we have something like secant of x plus tangent of x times secant of x minus tangent of x. When you have the exact same things in each set of parentheses and they're separated by opposite sides, what do you call them from Algebra 2? One of those magic Algebra 2 words. It starts with a C. Yes! Emmett Brown is on fire today. These are conjugates of each other. What always happens in conjugates? The middle two terms always cancel. Way to go, Taylor. Woo! We're doing good. So what's secant times secant? Secant squared of x. Outers and inners always cancel, so we don't even have to mess with them. Last times last is negative tangent squared. Now, this is very similar to one of our Pythagorean identities on our note card. Our Pythagorean identity on our note card says secant squared x equals tangent squared of x plus 1. So, how do I manipulate this into this? Just subtract tangent squared from each side, right? So this is equal to 1. All right. Let's do another one. Let's say we have secant squared of x plus 1 times secant squared of x minus 1. Oh, not squared. No, that'll make it too big. Let's just go secant of x plus 1, secant of x minus 1. All right. So, are they conjugates? Yeah. So secant times secant is secant squared. Outers and inners is minus 1, right? Outers and inners cancel. Last times last is minus 1. Now, looking at our Pythagorean identity that we have kind of hidden behind that triangle there, what do we do? What does it look like? What's the difference between this and this? We did what to each side? Subtracted 1. So if we subtract 1, what's left on the other side? Well, it's tangent squared of x. Boom. Bada bing, bada boom. We're done. That's it. All right. What if I have cosine of x over sine of x plus sine of x over cosine of x? What would that work out to be? Well, when you add two fractions, they need to have common denominator. Look at this at elementary school. That just paid off. All those things they talked about in elementary school math. All right. So what's our common denominator going to be here? If they aren't the same, what do you do? Multiply them by each other, right? Yeah. So what would I multiply the second fraction by? Sine of x over sine of x. What would I multiply the first fraction by? Cosine of x over cosine of x. So our common denominator is going to be cosine sine. So what's cosine times cosine? Cosine squared of x over cosine sine. Our second fraction is sine squared of x over cosine of sine. So I have cosine squared of x plus sine squared of x over cosine of x sine of x, right? What's cosine squared plus sine squared? 1. So I have 1 over cosine of x sine of x, which I could say is 1 over cosine of x times 1 over sine of x. What's 1 over cosine of x equal to? secant of x. What's 1 over sine of x equal to? Cosecant of x. I could stop there. I could even stop there. Okay? And when we get into trig identities, you'll have a stopping point. You'll know exactly where you're supposed to head. Okay? So, what we're doing on the first little area is just matching. You're matching the problem with the answer. 1 through 10, all, page 172. That's what we're doing before lunch. 1 through 10, all, page 172.